Hello everyone. In this lesson we're going to talk about measuring, dimensions, and units. And so when we talk about measuring, what we have to keep in mind is a measurement's not a number. It's not only a number, I guess. So imagine we have these two marks and we want to know how far apart they are. What we're interested in is this distance, this length, right? And that length is what we call a dimension. And so there are different dimensions that we can measure. We can measure how far apart things are length, but we can also measure how much time it takes for two events to occur. And so another dimension that we have is time. Or we could measure how much matter is in something, and that's a dimension of mass. Or we could measure how much charge is in something. That's a dimension of the dimension of charge. We use the unit of Coulomb. So these three, length, time, and mass, these dimensions we're going to use over and over and over and over again in physics. And we will combine them in a bunch of different ways to get other units. Like we can measure force, we can measure velocity. Those are going to be derived from these units, or these dimensions. And so these dimensions of length, time, and mass, these are our base dimensions, and we will derive other dimensions combining those things. Now, when we make a measurement, I said it's not a number because we need a standard scale. How far apart are those? Well, what do you want to measure in? Do you want to measure in centimeters? Do you want to measure in inches? Do you want to measure in feet? Do you want to measure in miles? You have to choose. You have to pick a unit, right? So the unit is your choice depending on the dimension that you pick, right? I can't say how far apart those are in seconds because seconds doesn't describe a distance, but I can pick inches and I can pick centimeters. Both of those are valid. So let's say that that's 10 inches. Okay. Well, that number is only there because I picked that unit. If I had picked a different unit, say centimeters, that distance didn't change, so 10 inches, it turns out, is the exact same thing as 25.4 centimeters. Now this equality here is an interesting thing. You'll notice the number doesn't match. You'll notice the unit doesn't match, right? So how can I say two things that are very clearly not the same number or unit are equal to each other? Well, it's because a measurement is actually describing something in real life, a physical thing. And it's just these two numbers and units together, these measurements are describing the same thing. And so they are equal to each other because they're the same object. And that gives us the idea of unit conversions and the idea that we can, in fact, change one unit into another, but the number that goes with that unit also has to change, right? So the unit is a choice that depends on the dimension. But the number that goes with that measure is decided by the unit. Right? And in science, and especially in physics, we're going to have some very common units that we use over and over again. Our base unit for length is going to be the meter, and we abbreviate meter with a lowercase m. For mass, our base unit is the kilogram. You'll notice that's not a gram, that's a kilogram. It is 1,000 grams, kg. And our base unit for time is going to be the second. And we'll abbreviate that S. So we use the dimensions of length, time, and mass, and the units of meters, kilograms, and seconds, and then we can combine those units to get other things. Like, for instance, we could get an area. If this is a 4 centimeter and this is 4 centimeters, then the area, 4 centimeters times 4 centimeters, is equal to 16 square centimeters. Okay? A square centimeter doesn't describe a length. A square centimeter describes an area. We could describe a velocity. If we covered, say, 1 meter in 3 seconds, 1 meter, let's go 4 seconds, in 4 seconds, then what we have is a velocity of 0.25 meters per second, right? That unit doesn't describe length or time. It describes length per time, and that's called a derived unit. So that's a velocity. And so we will have derived units, and we will have base units, and we will have unit conversions. And the trick to any unit conversion is figuring out this relationship between the two units. And then, because they're describing the same thing, because, say, 10 inches equals 25.4 centimeters, we can divide both sides by 10 inches, and we treat those units as though they're algebraic quantities, so they cancel out. So I have 10 divided by 10, which is 1, equals 25.4 divided by 10 is 2.54 centimeters per inch. And so this thing is called a unit conversion because the right side and the left side are equal. We can multiply a measurement in inches by 2.54 centimeters per inch and end up with what that is in centimeters, right? So we can convert, say, 34 inches into centimeters simply by multiplying by 2.54 centimeters per inch. These inches will cancel those inches, and then all we have to do is that algebra, 34 times 2.54, and get whatever, about 90-ish centimeters that length is. So we'll use unit conversions, and we will use the metric system in physics.